my name is NATASHAH. This is my student ID.
Hi, my name is AISYAH, and here is my student ID.
My name is FARIHAH, and this is my student ID.
My name is Lailatul. Here is my student ID.
The meaning of differentiation. The derivative measures how a function changes as its input changes. It tells us the rate of change or slope of a function at any given point. In this case, the derivative is the cos speed because speed is the rate of change of distance with respect to time.
Given a function of fx equals to 3x squared minus x, if you want to differentiate normally, you'll get f prime x equals to 6x minus 1. However, if you want to differentiate using a definition of derivative, we need to use a specific formula. We need to use the formula of f prime x is equals to limit h approaches to 0 as x plus h minus fx over h. So given the same function, fx is equal to 3x squared minus x, if you use the definition of derivative formula, we'll have to find the fx plus h first. We have to sub in everything that we calculate into the formula. We just expand the equation and then we'll get the same answer as the normal way we differentiate.
I will be explaining the techniques of differentiation, specifically the derivative of constants, linear, and power functions, and how we use the sum and difference rules. Okay, first, constant function. The constant functions look like fx equals to c, where c is a number. The derivative of the constant is 0. Second, linear function. A linear function is like this: fx equals to ax plus b. The derivative of this is just the coefficient a. Third, power function. A power function is like this: fx equals to x power of n. The derivative is d over dx x power of n equals to n x power of n minus 1. Now, how do we differentiate if we have more than one term? We use the sum and difference rules. Term, if fx and dx are both differentials, then d over x fx plus dx equals to f prime x plus g prime x, and d over dx fx minus dx equals to f prime x minus dx. This means we differentiate each term separately.
Hey guys, sit down. Now, let's relearn about the techniques of product rule, the third techniques, okay? The theorem of the product rules is let y equal to u multiply v, where u and v is the two differentiable functions. Then, with this information, we can write the formula like this: dy over dx equal to u multiply dv over dx plus v multiply du over dx. Or, the short one is dy over dx equal to u multiply v prime plus v multiply u prime. That's all.
Next, I will explain about the chain rule. Chain rule is a technique for finding the derivative of composite functions, with the number of functions that make up the composition determining how many differentiation steps are necessary. It means that how many differentiation steps are necessary based on the number of functions. For case 1, we use the first equation when there are two functions and we have two steps to differentiate it. For the second equation, we use it when there are three functions and we have 3 steps to differentiate it. For the case 2, we can use the formula which is dy over dx equals to dy over du times du over dx.
I will explain the last technique of differentiation, which is quotient rule. We can apply quotient rule on the rational function where u and v are two differentiable functions. Then the formula is dy over dx equals to vu prime minus uv prime over v squared. So let's look at the example. So this is the example for quotient rule. The question is if y equals to 1 minus 2x over x squared plus 3, then we need to find the dy dx. So on this question, we can apply a quotient rule where u equals to 1 minus 2x and v equals to x squared plus 3. Then we need to differentiate the u, becomes u prime equals to minus 2 and v prime equals to 2x. Then we can apply it on quotient rule. Then we can expand these one by one and we get the answer. Okay, so for this question, find dx for 3x squared second x plus 2. We can apply product rules to this question because 3x squared and second x plus 2 is two differentiable functions. U is the 3x squared, and then we need to differentiate u into u prime, so we will differentiate become 6x. V is equal to second x plus 2. We need to use derivative of trigonometry. As you can see in the bottom, second x when differentiate will become second x 10x. So we apply that into this. V prime is equal to second x plus 2 10x plus 2, and then we need to differentiate inside of the bracket. So when we differentiate 2 will become 0, differentiate x will become 1. So we just multiply by 1. We sum in all of these inside of the formula of our product rule. When we sum in, we have to extend each of them, and then we get the answer.
Hi everyone, today I will show you how to find the derivative from this equation. Y equal to 4x plus 2 divided by cos x. This is the fraction, so we must use the equation rule to find the answer. First, the top part we call as u, so u equal to 4x plus 2. The derivative of u is u prime equal to 4. So the bottom part we call as v. V equal to cos x, so the derivative of v is v prime equal to negative sin x. So after we get the both derivatives, we must include this into the formula, equation rule formula. So the equation rule formula is y prime equal to v multiply u prime minus u multiply v prime divided by v square. So we must put this into this formula. We will get the y prime equal to cos x multiply 4 minus 4x plus 2 multiply negative sin x divided by cos x squared. So we arrange this fraction to look the neat and organized. So we will get the 4 cos x plus, we must put the bracket into 4x plus 2 multiply sin x divided by cos x squared.
Next, I will explain from question 3. Given y ln 3x minus e to the power of 2x plus 1 minus tangent of 4y equals to 0, find dy over dx using implicit differentiation. Firstly, we need to differentiate all of this y by 1. When we get at this function, we see that there are two differentiable functions, which is y ln 3x. So we need to apply product rule for this function. Then we can assume u, y as u, and ln 3x of v, and differentiate it become u prime equals to 2 over x, and v prime equals to 1 over x. Then we can apply all of this on product rule. This is the result of the differentiate it by using a product rule. And for e to the power of 2x plus 1, we can differentiate it by times it 2. And for tangent of 4y,
So here I am using the technique of differentiation, which is chain rule. Because first step, I need to differentiate tangent of 4y becomes secant square of 4y. The second step is we need to differentiate the value in the bracket, which is 4y becomes 4 times dy over dx.
and then we just need dy over dx at the right side and let the others to the left side. For this one, we need to make the denominator algebraic and become 2x e to the power of 2x plus 1 minus y over x. Then we need to let dy over dx become the subject, and for the function, we divide it by 1 3x minus 4 secant square of 4y. And we're not supposed to have 3 layers for this, and we need to times it with 1 over ln 3x minus 4 secant square of 4y. So here is the final answer. For the last question, I will just use linear approximation to estimate the value of 4 root of 80.99 minus 2 over square root 80.99 correct to the 3 decimal place. So I will explain how to estimate the value of this expression using the linear approximation. Okay, for step 1, we need to define the expression 4 root of 80.99 minus 2 over square root 80.99 become 4 root of x minus 2 over square root x. Step 2, we need to derive the functions from this, become this. So the x 1 over 4 minus 2x negative 1 over 2 become 1 over 4 x 3 minus 3 over 4 plus x minus 3 over 2. So this is the final answer of f prime. Okay, next let's move to step 3. Okay, for step 3, we need to choose the easiest numbers to calculate, which is x is 80.99. So we choose x0 as 81. So the change in x is x minus x0, and the final answer is negative 0.01. Okay, for the last step, we need to apply the linear approximation formula, which is the formula is fx equals to f at 0 plus f prime at 0 multiplied by x minus x0. So the step is we need to substitute in the